actually in the world of physics, not only are we related to all living things, but we are related to the earth and the universe. You and I, and every living thing has minerals in it that it cannot live without. We are related to the earth. That's what the term relativity, and incidentally, the term relativity came into being, no, relative. The word relative came into being around 1500, about 500 years ago. And this is, it seems like a year ago, I looked in the OED and came up with these years, but I could be corrected on this. And the term relativity is less than 150 years, or right at 150 years old. So it's a new term. Now, but intellectuals were beginning to think about this because of the first law of thermodynamics back in the late 19th century. And there was a book written in 1855 by a German physicist by the name of Ludwig Buchner, simply titled Force and Matter. And very powerful work. You can download it off the internet. All you got to do is look up Ludwig Buchner and you'll find it. It's B-U-C-K-N-E-R, and I got the little umlaut over the U. And it's a staggering idea that the intellectuals were beginning to think in that era. And you can see the evolution as it came into today. The three essays that were called Relativity and the Photoelectric Effect is what helped Einstein to get his PhD in physics and get to become a professor, which in that day and time, anybody in the German world, the ultimate sign that you have arrived was to become a professor. If you had the word professor by your name, you had arrived. And it was relativity. Well, actually they gave him his PhD, his PhD for the photoelectric effect. But it's relativity that got everybody's attention. And they knew the ramifications psychologically and intellectually of relativity, and they wanted to maybe not give an additional validation to that, so they gave Einstein his PhD based on the photoelectric effect. Gravity. It seems as though, now in 1905, when his three essays on relativity, and it was called Special Relativity in 1905, it seems as though the world liked the idea. He was opening the doors to knowledge, and I mean, it made the 20th century one of the most incredible century in all of history. But then, he had some additional thoughts. So then, 10 years later, he had finished General Relativity in 1915, but he did not publish it until 1916. And that's where he apparently destroys that's apparently where he destroys the idea of Newtonian gravity. And I'm still trying to wrap my mind around this, and I'm just going to throw this out to you. This is the way I understand it at this point, and I need to know more before I would say this represents total insight into Einstein and general relativity. But it appears as though, and I think it was Neil deGrasse Tyson on Nova, but I could be corrected on that, and believe me, things on the internet and on television, I don't know that, I think they should all be taken with a grain of salt. But apparently, when Einstein in General Relativity in 1916 publishes his papers, he destroys the Newtonian notion that when that apple fell from the tree, that it was attracted by gravity, pulling it to the ground. That apparently is not the case. Apparently, there is different gravitation, what we would call gravitational pulls, which is not correct. And that's one reason why relativity has helped them to understand that there's going to be a different gravitational force on different planets and stars and that sort of thing because of their size. The bigger, you know, the greater the gravitational pull. But relativity apparently says, and if you folks quote me, please use that word, because I'm not saying it is this way, but it seems, from what little bit I know at this point, this way, that it is the curvature of time and space. And incidentally, you have no time if you have no space. You have no space if you have no time. And Einstein was saying that the curvature of time and space is pushing things, not an attractive force inside. Although both books of Stephen Hawking here, he uses the term attractive to describe gravity. That's one reason why I'm trying to be as humble as I know how here in relationship to this subject. But look at this marker. Am I pulling this marker towards me? Am I pulling this marker towards me? Now, I'm not holding on to it, but it's coming towards me. I'm pushing it. The end result is the same thing. So, if the apple goes to the ground, is there an attractive force inside, say, let's just say the electron force, or what have you, that's pulling it to the earth? Or is it the curvature of time and space that is over it that is pushing it? And one of the things that helped me to understand this, I think, and somebody like some of these professors could enlighten me, but if you think of a drop of water, say that we've got a leaky pipe and it's in the ceiling, and one drop comes down, and you see it forming there, and finally it drops, and it's round on the surface, but it's got a little tail on the end. Is it being pushed? Or is it being pulled? You would think if it was being pulled, it would have that point on the front, not on the back. I honestly don't know, but I'm asking a question. And I think it's a good one. Not like the physicist to tell me what I don't know. We wanted to have a question and answer time, and I have a lot more to say, but I think I've opened enough doors and question marks, hopefully. And I don't know that, if you were to ask a question, I don't know that I can answer it, but I'd try. Or I would defer it to some of the professors here. Any questions? Shoot.
Is determinism, is that the controlling factor of singularity?
They can determine laws of physics that are involved there. And I don't know how many would be, but yes, I am also a psychological determinist. Simply, and I think it is our vanity that gives us what religion says is free will. If I was Dr. Where's Becky here? And if I was born, I had the same DNA and same genetics, same parents, same experiences in his childhood, same friends, same everything. I would not be like him. I would be him. Exactly. Same thing is true if you were me, or Dr. Wood, or anybody in this room or anywhere in the world. And so I'm a psychological determinist, and remember when I said that the uncertainty principle that evolved, I think, from Brownian notion of motion, that the uncertainty principle seemed to modify in physics determinism. And I would say, I think it's just a matter of time before we discover the formula that can predict this random motion. So I'm a thoroughgoing determinist, physically and psychologically. But that is a very debatable subject. You understand what I'm saying? And I don't want to extract any dignity from the human race whatsoever.
Ross, I know that some of our Odyssey people here have a 1:30 class, is that right?
Yes.
To go to, but I also know that many people in the room probably have questions for you. So what I'd like to do is break right now, allow our Odyssey people to go to the Humanities building if they have a class. And those of you who would like to stay and ask questions of Ross, please feel free to stay. Sandwiches and drinks.
Let's thank
I always tell Ross that he's the one man that makes me think, probably more than anyone else in life. And he has certainly done that for me today, and I hope he's done that for you. Thanks again.
Thank you. Thank you very much.
What do you think? Physics is a difficult concept for people.
Thank you.
Really is. I'm waiting till the end. I want to save all mine for the end.
Good. I'm letting it sink in.